Okay, hello everyone, welcome to my channel. And I'm going to do a tutorial. And actually this is a past paper, a chemistry past paper, and this question is regarding your knowledge about air. So even I haven't gone through the questions yet, so we will together try to find the answers for this question. Okay, let's read. Many electricity generating power stations burn fossils. The combustion of these fossil produced waste waste gases called flue gases. So you know for a fact that in countries where hydropower, nuclear power, wind power, or whatever the renewable or non-renewable sources are not available, the main source of generating electricity is burning fossil fuels, and this could lead to many problems. For example, these combustion of fossil fuels produce waste gases such as nitrogen oxide, as you can see here, and sulfur dioxide and carbon dioxide. Fossil fuels mainly contain carbon and hydrogen because these are hydrocarbons. So when carbon combines with oxygen, it produces carbon dioxide, and sulfur is also contained in hydrocarbon small amount. Once sulfur is combined with oxygen while burning them, sulfur dioxide is formed, so is nitrogen. Nitrogen oxides are formed. Nitrogen oxides and sulfur dioxides contribute towards acid rain. So these are acidic gases. Once they combine with rainwater, since then the gas is formed in the atmosphere, they can react with rainwater while raining, and this will produce acids, causing many other hazardous results. This is bad for statues, plants, animals. Skin irritations occur because of atmosphere. So many. This is a whole other area. So acid rains are formed. Okay. To reduce these bad effects, flue gases should be removed uh, before before these um, combustive gases are released to the atmosphere. So part A asks, one of the nitrogen oxides is nitrogen monoxide. Mono here means one, so there should be only one oxygen. As you can see here, it's one oxygen, nitrogen monoxide. Okay, so then they ask you nitrogen monoxide is formed by the direct reaction between oxygen and nitrogen. Construct the equation for the reaction. So you have been asked to write an equation. So let's go ahead and try to answer this. Let's get the pen. I think it's okay. So here, uh, this this can be formed uh, by reacting oxygen and nitrogen. It says so. So you can just go ahead and write oxygen. You can find oxygen in this is a diatomic gas plus again nitrogen. So nitrogen is also diatomic gas, which has triple bond, and oxygen has double bond, by the way. And once these two reacts, you will get nitrogen monoxide apparently. Okay, so this is your reaction, but not yet. You're not done yet. You have to balance this equation first, and here you have two oxygen atoms, but in this side you only have one oxygen atom. So either you can add half in front of each of these two reactants, or just simply make it 2. It's like it's not good to have half values as the coefficient, so you better write 2 here, and remember to include their physical state which is the gaseous state in this case. Nitrogen monoxide is a gas, also is nitrogen, and again O2 is also a gas. So you will get full marks for writing such a reaction with the physical state and a balanced equation. Let's move on to the next question. When called nitrogen monoxide, so we are talking about the product here, comes into contact with oxygen, it forms nitrogen dioxide. So di means two, as you can see here, two oxygen atoms are there, so nitrogen dioxide. Construct the equation for this reaction as well. Easy, right? So we already have nitrogen monoxide. Just write what the question says first, and try to be logical and get the answer. So yeah, nitrogen monoxide, and it further reacts with oxygen apparently. So here you have oxygen, and the question itself says that you'll end up with nitrogen dioxide. Okay, so dioxide 2. Okay, you're done with the reaction. Check if this is balanced or not. You have one nitrogen atom here, one atom, okay, with nitrogen, two oxygen here, and here one oxygen, altogether three in this side, but here two. So now this is not balanced, so you can try your own methods, but you will end up with this. You just have to add 2 in front of this as the coefficient and 2 in front of this, so you can count 2 nitrogen atoms here. This 2 belongs to both or all of the atoms here, so 2 nitrogen atoms, 2 nitrogen atoms, you are done. 2 oxygen atoms here and 2 oxygen atoms, altogether 4 oxygen atoms, and 2 into 2 again 4 oxygen atoms. So there you have your equation. Don't forget the physical states, so gaseous, gaseous, and gaseous inside brackets. Okay, just nice and slowly, just you will get full marks for this reaction undoubtedly. Okay, let's move on to the next question. Some power stations spray the flue gas. Some power stations spray flue gas with seawater. This removes about 99% of the nitrogen dioxide and sulfur dioxide. The gas reacts with water to form aqueous acids. Nitrogen dioxide form nitric acid and another acid with the formula HNO2. Construct the equation for this reaction. Again, don't this is very simple. Just write down what the question says. So you have nitrogen here. Yeah, here from here onwards. Just write whatever they're saying. Nitrogen dioxide. So you know what the formula of nitrogen dioxide is NO2. NO2, which is in the gaseous form. I'm just gonna write it here while I'm writing this as well. Plus H2O. Okay, right. This forms nitric acid. Seawater means basically we are taking H2O. We consider that this is a reaction between H2O, which is in the liquid form, by the way. So to indicate that it's in the liquid form, you can just write L within brackets here. This forms, it says here nitric acid. You know the formula for nitric acid is HNO3, right? Okay, sorry about my handwriting, by the way. Okay, HNO3. This is a reaction with H2O, so obviously this is in the aqueous form. To indicate aqueous, you can just write AQ within brackets. That will give you the idea. And it also says that it forms another product called HNO2. So go ahead and write that as well. Just don't think too much. it says so in the question. And if you know chemistry, this is the reaction HNO3 and HNO2. This is also in the aqueous form. Okay, so there you have your reaction. Check if this is balanced. If you check carefully, one nitrogen atom, you only have one nitrogen atom here, so you just try 2 as the coefficient here. Now count. Okay, now you are okay with nitrogen. Now count all the oxygen atoms. You have 4 here and 5, altogether 5 oxygen atoms. Here you have 3 and 2, 5. Voila, there you have your reaction. So okay, so okay, that's the question. And the okay, okay, I hope that was clear for you, by the way. And let me close this, and we'll move on to the rest of the question. Okay, so here you have, in other words, sorry, in other power stations, the flue gases are reacted with moist calcium carbonate, and this removes about 90% of the nitrogen. So notice that it's 90% here, but earlier when reacting with seawater it was 99. See, it was 99, but here, so it's less efficient. Of the nitrogen dioxide and sulfur dioxide from the flue gas. Sulfur dioxide react with calcium carbonate to form solid calcium sulfite. Suggest a name for the other product. Okay, so one product is given. You're reacting calcium carbonate, which is moist calcium carbonate, by the way. Moist means H2O is there. You're reacting this with sulfur dioxide, which is a acidic gas here. And acidic gas plus moist means an acid, so base could be it should be H2SO4, and acid is reacting with a carbonate here, calcium carbonate. Obviously it's a, you know from your inorganic, when carbonate react with sulfur dioxide, there must be carbon dioxide. That's like, you know, a rule. So carbon dioxide is formed whenever an acid is reacting with the carbonate. Okay, so carbon dioxide is the answer for that. The nitrogen dioxide reacts with calcium carbonate to form two salts. Suggest names and the formulas. Okay, so again, calcium is, this is a carbonate. The acid that is formed from nitrogen dioxide, as we discussed earlier, is there were two acids, if you can remember. One was HNO3 and the other one was HNO2. I hope you remember. We just wrote the equation, by the way. And this is HNO2, HNO2. So the two salts should be calcium nitrate and calcium nitrite. So you just go ahead and write calcium nitrate. Nitrate is 3, and since calcium has the valency of 2, this is a 1 salt. And next one is calcium nitrite, NaO2 twice, because calcium has the valency of 2. Actually this should be in the formula row. You can just go ahead and write the name calcium nitrate and calcium nitrite. Okay, so that's it for that. I mean, the rest of the question is this. suggests two advantages of treating flue gas with seawater rather than calcium. Okay, obviously you can find the answer in the question itself as well. As you can remember, seawater has the efficiency around 99%, while calcium carbonate gives you a percentage of 90. So you can just write seawater is more efficient. That's a one. You can also write seawater is cheap rather than calcium carbonate. Also, to get to calcium carbonate you have to do mining, so no mining is required when seawater is used, so no landscape destruction. And also you can write that seawater is readily available. Well, this depends on the area, so if it's coastal area anyways, seawater is readily available and cheap. So in many ways seawater is much better. Okay, the last one, carbon dioxide is a greenhouse, so more carbon dioxide in the air, more heat is trapped in the atmosphere. This is because it's covalent bonds that can absorb infrared radiation. Infrared means IR, which is responsible for the heat radiation, which is basically the heat radiation IR. Draw dot cross diagrams to show the bonding of a molecule of carbon. Okay, so just dot cross, right? Okay, so in the middle you have carbon, which has 4 outer electrons. I'm just gonna use crosses here. Okay, okay, 4 electrons, so 4 crosses in the carbon. And in the carbon dioxide you have 2 oxygen. I'm gonna use another colors. So you have oxygen here, and you have oxygen here as well. So oxygen on the other hand has 6, since this is a covalent bond. Oh my god, I'm really sorry about my drawing, by the way. 6 electrons. So since oxygen forms double bonds here, sorry, this should be a dot. This should be a dot. Wait, I'll show you. That's easier. There was is this right? Okay, so one second. It's not clear, right? I hope this is like there should be 4 bonds, basically like a dot cross, a dot cross, so that represent a double bond. Here dot cross, dot cross, that's a double bond. In between you have carbon and oxygen here as well, and the rest of the oxygen atoms electrons are also present. So that's how it goes, by the way. That's okay. I hope this was really clear for you, and I'll see you with a full paper discussion really really soon. So let me sign out, and if you have any questions, by the way, if you want me to do a specific set of questions, please comment below, and I will try to get it done. Okay, thank you.